Hi friends, welcome you all to Think Maths. We are in class 11 Maths, chapter 2, Relations and Functions. So in this chapter, we are going to discuss about exercise 2.2, all the questions. That is question number 1 to 9. So with this, exercise 2.2 will be completed. So let us get into the problems. First one, let A is equal to set of all 1, 2, 3 up to 14. Define a relation R from A to A by R is equal to set of all x comma y such that 3x minus y is equal to 0 where x comma y belongs to A. Write down its domain, codomain and range. Already in the previous video we have discussed what is a relation, what is domain, codomain and range. So if you haven't seen the video, just check my channel and you will get the link for that introduction part for relation. Okay. Next one here. It is given that relation is set of all x comma y. So this relation is defined from A to A. That is the relation is on A. The same set A to A. Here A is 1, 2, 3 up to 14. So what is the relation? 3x minus y should be equal to 0. So this is the relation. Here x and y should belongs to A. That is the relation. So now just check. Let me start the solution. Here what is given? 3x minus y equal to 0. Now what will happen? Keep this 3x as such. Minus y, when I take this to right hand side, it will become plus y. That means 3x equal to y can be written as y is equal to 3x. So y should be 3x to satisfy this equation. So now let us form the table. So the table is here x. And what is y? Y is equal to 3x. Now we have to check whether x and y both belongs to A. Okay, here x comma y belongs to A. If both x and y belongs to A, then we can form the we can form the relation. That is, we can form the relation in roster form. So this is given in set builder form. So we can form the relation in roster form so that we can easily find out domain, codomain and range. So let us check what are all the elements. Now A has 1, 2, 3, 4, 5, 6 up to 14. So let us take one by one. So when x is equal to 1. Okay. What is y? Y is equal to 3 into 1. It is 3. So 1 belongs to A. 3 also belongs to A. Yes. This condition is satisfied. Next let us take T. 2. What is 2 into 3? 2 into 3 is 6. Yes. 2 belongs to A and 6 belongs to A. Yes. Next we take 3. What is 3 into 3? 3 into 3 is 9. And 9 belongs to A. Correct. So next you take 4. What is 4 into 3? It is 12. Is 12 in A? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 12 is in A. Yes. Next you take 5. What is 5 into 3? 5 into 3 is 15. Is 15 in A? No. Only up to 14. So it is not in A. So next you take 6. What is 6 into 3? It is 18. 18 in A? No. So it is not in A. So after this, it will increase after 14. That is, the number will be greater than 14. So we cannot take 7, 8, 9, 10, 11, 12, 13, 14. So after 5, y value is increased, that is increased after 14. Okay, so we get the values for y after 14 from x is equal to 5. So we will take only up to 4. Understood? So now R is the relation. So let us write the relation in roster form. How do you write? It is open the set bracket and open the curly bracket. What are the relation? 1 comma 3. 1 comma 3, 2 comma 6. Take this 2 comma 6. So 2 comma 6. Next one is 3 comma 9. Next one is 4 comma 12. So these are the things that satisfies x comma y belongs to A. So it is 4 comma 12. So this is the relation in roster form. Now we have to write domain. What do you mean by domain? Domain is nothing but set of all first element. So set of all first element in relation, that is in R. So what is the first element? 1, 2, 3, 4. So set of all 1, 2, 3, 4. So this is the domain. Next, what is codomain? What do you mean by codomain? Set of all elements in second set. So what is the second set here? Here both are same. It is the relation is defined from A to A. From A to A. So the second set is also A. So that is A. What is A? It is nothing but 1, 2, 3 up to 14. So this is the codomain. Next, range. What do you mean by range? Range is nothing but set of all second elements. Set of all second elements in R. So in R, what is the second element? 3, 6, 9, 12. So we will write range is equal to 3, comma 6, comma 9, comma 12. So this is the range. Okay, understood? So shall we move on to the second question? Second question, define a relation R on the set N of natural numbers by R is equal to set of all x comma y such that y is equal to x plus 5. X is a natural number less than 4. X comma y belongs to N. That is, both x and y should be in a natural number system. Depict this relationship using roster form. Write down the domain and the range. Now, in the same way as in the previous problem, we have to find out the values of x and y. So, here let me take x and y is given as x plus 5 and we have to check whether x comma y belongs to the natural number system. What is natural number system? It is nothing but starting from 1. 1, 2, 3, 4, etc. Now, what is the condition? X is a natural number less than 4. So, what are the numbers less than 4? It is 1, 2, 3. So, X takes the value 1, 2, 3. Now, what is Y? Y is X plus 5. 1 plus 5, 6. 2, when X is equal to 2, Y is equal to 2 plus 5, 7. When X equal to 3, Y is equal to 3 plus 5, 8. So here x belongs to natural number and this y also belongs to natural number. 2 belongs to the natural number, 7 belongs to natural number. Yes. 3 belongs to the natural number, also 8 belongs to the natural number system. So now let us write the relation in roster form. Depict this relation using roster form. Roster form is R is equal to set of all. What are the ordered pairs? 1, comma 6, 2, comma 7, 3, comma 8. So these are the ordered pairs. So we form the relation in roster form. Now we have to find out the domain. What is domain? Set of all first element in the relation. So what are the first elements in the relation? It is 1, 2, 3. So what is range? Range is nothing but set of all second element 6, 7, 8. So this is the range. Okay, very easy, right? So let us study the third question. A is equal to 1, 2, 3, 5 and B is equal to 4, 6, 9. Define a relation R from A to B by R is equal to set of all x comma y such that the difference between x and y is R. X belongs to A, Y belongs to B. Write R in roster form. Okay. Here we have to check whether the difference between x and y is odd. So here two sets A and B. So first let us form the Cartesian product so that we should know how many ordered pairs we can form. How will we form the Cartesian product? Take an element, first element from first set A and pair it with all other elements in the second set B. So it is 4, 1 comma 4, 1 comma 6, 1 comma 9. Next take the second element and pair it with all the elements in B. So it is 2 comma 4, 2 comma 6, 2 comma 9. Next take the third element 3 comma 4, 3 comma 6, 3 comma 9. Next take the fourth element which is 5 and pair it with 4, 6, 9. So 5 comma 4, 5 comma 6, 5 comma 9. So this is the Cartesian product between A and B. Now what is the relation? The relation says that the elements are from A and B. So x belongs to A and y belongs to B, and the difference between x and y is odd. Okay. So this is the condition. Let us find out which elements do they belong. So let us take x, y. So what are the first one? First ordered pair is 1, 4. That is x equal to 1 and y is equal to 4. So it is 1, 4. We have to find out the difference x minus y. So what is 1 minus 4? It is minus 3. This x minus y should be odd. Is it odd? Yes. 3 is an odd number. Yes. Next to 1 comma 6. So 1 minus 6 is minus 5. Is it odd? Yes. 5 is an odd number. Next, I wrote, I'm sorry, I didn't write 9 here. Just a minute. So it is 1 comma 9. So take 1, 9. What is the difference? 1 minus 9 is minus 8. Minus 8 is even. So it doesn't come. Next take 2, 4. So 2 minus 4 is minus 2. So minus 2 is even number. Next 2 comma 6. 2 comma 6. What is 2 minus 6? 2 minus 6 is minus 4. This is also even. Next 2 comma 9. What is 2 minus 9? It is minus 7. Okay. So minus 7 is odd. So we can take this. Next 3 comma 4. What is the difference between 3 and 4? It is minus 1. It is odd. Next 3 comma 6. So what is the difference between 3 and 6? 3 minus 6 is minus 3. Minus 3 is also odd. Next 3 comma 9. Okay. So what is 3 comma 9? 3 minus 9 is minus 6. So it's it minus or plus. That is not needed for odd or even. Just you have to check the number. So 6 is even. So it doesn't come. Next 5 comma 4. What is 5 minus 4? It is 1. Yes, it is odd. Next 5 minus 6. 5 minus 6 is minus 1. It is also odd. 5 minus 9. It is minus 4. Minus 4. 4 is an even number. Okay. Now we have to form the relation that satisfies this condition. We have to form the relation for only tick part. So let us form the relation in roster form. So R is equal to set of all who are all coming 1 comma 4, 1 comma 6. Next this 1 comma 9 is wrong. 2 comma 4 will also not come. 2 comma 6 will not come. So 2 comma 9. 2 comma 9. Next 3 comma 4, 3 comma 6. So next this 3 comma 9 will not come. 5 comma 4, 5 comma 6. So now this is the relation in roster form. Okay children, understood? Is it clear? So let us move on to the next problem. Fourth one. The figure shows a relationship between the sets P and Q. Write this relation in set builder form, roster form. So here there is a set P with the elements 5, 6, 7. And there is another element, another set Q with the elements 3, 4, 5. Now if you check, 5 is paired with 3. 6 is paired with 4. 7 is paired with 5. So just if you look at it, 5 and 3. The difference is 2. 6 minus 4 is also 2. 7 minus 5 is also 2. So that is the difference between these two numbers is 2. That is the relation. So we get 5 minus 3 is equal to 2. 6 minus 4 is equal to 2. 7 minus 5 is equal to 2. It is x minus y. If you take the elements in P as x and if you take the elements in Q as y, we get the relation x minus y is equal to 2. Understood? So this is the relation. Now we have to write this in set builder form and roster form. Now let us define the elements of P as x. So therefore x belongs to P. And the elements of Q as y. Therefore y belongs to Q. Now for the first question, it is set builder form. Set builder form means R is the relation such that what are the ordered pairs? X comma y such that what is the relation? X minus y is equal to 2. X minus y is equal to 2 and this x should belongs to P and y should belongs to Q. So this is the set builder form for the given relation. Now second one, roster form. Roster form. Now we have to write the ordered pair. 5 comma 3, 6 comma 4, 7 comma 5. That's all. 5 comma 3, 6 comma 4, 7 comma 5. So this is the relation in roster form. Okay. The first element should be from P and second element should be from Q. So this is the rule you have to follow to write in roster form. Okay. Next, what is the question? What is its domain and range? What do you mean by domain, children? It's so simple. That is set of all elements in the set of all first element in the ordered pair. So it is 5, 6, 7. 5, 6, 7. This is the domain. What is range? Range is set of all second element in the relation. Okay, so it is 3, 4, 5. Simple, isn't it? So we have finished the fourth question. Next we will move on to the fifth question. Let A is equal to set of all 1, 2, 3, 4, 6. Let R be the relation on A defined by set of all A comma B such that A comma B belongs to A. B is exactly divisible by A. Okay. Write R in roster form. Find the domain of R. Find the range of R. So let us find out from the table what are the elements that satisfies this condition. So this roster form will be little big. So not roster form. Cartesian product will be little lengthier. So I am directly writing the elements of Cartesian product in the table. Okay. So here what is given? The relation is between A and E. Relation on A. That means relation is from A to A. Okay. So here A is 1, 2, 3, 4, 6. So the same relation, the same set. 1, 2, 3, 4, 6. Okay. Here the relation is between A and A. So how it is formed? The condition is B is exactly divisible by A. So how we will form the Cartesian product? We will take an element from first set and pair it with all other elements in the second set. So second set is also same. So first let us write this is A, B, B by A. Okay. So we have to take the first element. Let us write it in black. So first element is 1. So we should pair it with all other elements in the second step. So it is 1, 2, 3, 4, 6. 1, 2, I'm sorry. 1, 2, 3, 4, 6. So what is B by A? B is exactly divisible by A means B by A should be a whole number. Okay. So B by A should be whole number. So what is B by A? 1 by 1 equal to 1. Yes, it is whole number. 2 by 1 equal to 2 whole number. 3 by 1 equal to 3 whole number. 4 by 1 equal to 4. It is whole number. 6 by 1 is equal to 6. Yes, it is whole number. Next, in the same way. So here I am going to take the second element, which is 2, and pair it with all other elements. That is 1, 2, 3, 4, 6. 2 by 1, it is 2. Yes, it is whole number. Next, 2 by 2 is 1. It is whole number. 3 by 2 is not whole number. You will not get, it is not exactly divisible. So this will not come. Next, 4 by 2 is 2. So this is whole number. 6 by 2 is 3, and this is also whole number. Next, take A, B, B by A. So we took 1, we took 2. Next we are going to take 3. So the first element is 3 in the ordered pair. Second element, we have to pair it with all other. 1, 2, 3, 4, 6. So B by A. I'm sorry, here it is 1 by 2. Is it B by A? So it is 1 by 2. So 1 by 2 is not whole number. Okay. So all other things are correct. Yes. Here B by A, 1 by 3, it is not whole number. 2 by 3 is also not whole number because 2 is not divisible by 3. 3 by 3, yes, it is divisible. We will get 1. 4 by 3 is not divisible. 6 by 3 is 2. 6 is divisible by 3. So it is 2, which is a whole number. Next, A, B, B by A. So we took 1, 2, 3. Next we will take 4. So the first element will be 4. And the second element is 1, 2, 3, 4, 6. So B by A, it is 1 by 4 is not whole number. So 2 by 4 is 1 by 2. So we cannot divide 2 in the 4 table. So it is not a whole number. 3 by 4 is also not possible. 4 by 4 is equal to 1. So it is a whole number. 6 by 4 is not a whole number. Okay. So last table A, B, B by A. So we have to take 6 from here. So 6 and pair it with 1, 2, 3, 4, 6. So 1 by 6 is not a whole number. 2 by 6, yes. Is it? No. 2 is not exactly divisible by 6. So it is not a whole number. 3 by 6 is not a whole number. 4 by 6, no. It is not a whole number. 6 by 6 equal to 1. So it is a whole number. Understood, children? So if you get fractions, suppose if you take 3 by 6, it is 1 by 2. So it is not a whole number. It comes under integers. Okay. So not even integers, that is, it comes under rational number system. So here, if it comes under rational number system, we cannot say B is exactly divisible by A. So if it is exactly divisible by A, we should get whole number. That is 0, 1, 2, 3, or you can get integers also. Here they give only positive numbers. So we should get whole numbers. So wherever we got whole number, I put a tick mark. Now let us form the roster form for this relation. So R is equal to, here 1 is paired with all other elements, all got the tick. So it is 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 6. Now in 2, it is 2 comma 2, 2 comma 4, 2 comma 6. I am writing the ordered pair which got tick. 2 comma 4, 2 comma 2 I missed out. So 2 comma 2, 2 comma 4, 2 comma 6. Next one in 3 is only 3 comma 3 and 3 comma 6. 3 comma 3, 3 comma 6. Next in 4 it is 4 comma 4 and in 6 it is 6 comma 6. So we wrote the ordered pair which has a tick sign. So this is the roster form for this relation. So first part is over. What is the second part? It is nothing but you have to write the domain. So domain is the first element in the relation. 1, we have 1 and we have 2, we have 3, we have 4, we have 6. So this is the domain. Third question is range. So what is range? Range is nothing but second element. So second element is 1, 2, 3, 4, 6. So this is the second element. 1, 2, 3, 4, 6. I think others are all same. 4 is written, 2 is written, 6 is written, 3 is written, again 6, 4, 6. So they are all written. So we have to write it only once. So this is the range for this problem. Okay, children, understood? So shall we move on to the sixth question? Determine the domain and range of the relation R defined by R is equal to set of all x comma x plus 5 such that x belongs to 0, 1, 2, 3, 4, 5. Okay, so very simple. We have to find out just the ordered pairs. So let us form the table. So it is x plus 5. So what is x? 0, 1, 2, 3, 4, 5. We have to add with 5. So 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. 4 plus 5 is 9. 5 plus 5 it is 10. Very simple. Now we have to find out the domain and range. So let us write the relation in roster form. So we have to just form the added pair using this table. 0, 5, 1, 6, 2, 7, then 3, 8, 4, 9, 5, 10. So this is the relation in roster form. So now what is domain and range? What is domain? Domain is nothing but first element in the relation. 0, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. This is the domain. What is range? Range is nothing but second element. 5, 6, 7, 5, 6, 7, 8, 9, 10. 8, 9, 10. So this is the second element in the ordered pair. So it is the range. Which you understood? Very easy. So next move on to the seventh problem. Write the relation R which is equal to set of all x comma x cube. X is a prime number less than 10 in roster form. Okay. So here some conditions are given. So what? It is the relation between x, x cube. The ordered pair is formed between x and x cube. So who is x? X is a prime number. So prime number is 2, 3, 5, 7, 11. So it is less than 10. So prime number starts from 2, 3, 5, 7, 8, 9 are all not prime. So only 2, 3, 5, 7. So the x takes the value 2, 3, 5, 7. So what is 2 cube? 2 cube is 8. What is 3 cube? 3 cube is 3 threes are 9, 9 threes are 27. 5 cube, 5 fives are 25, 25 into 5 is 125. 7 cube, 7 sevens are 7 into 7 into 7. 7 sevens are 49, 49 into 7, 63, 9 sevens are 63, 7 fours are 28, 28 plus 6, it is 343. So 7 cube is 343. Now we have to write this in roster form. Roster form means what? Just we have to write the numbers in ordered form. It is 2, 8, 3, 27, 5, 125, 7, 343. So if you write, you have to use the curly bracket. It is the relation between x, x cube. So for 2, we found the answer as 8. For 3, we found the answer as 27. For 5, we found the answer as 125. For 7, it is 343. So this is the roster form. Okay, children? Understood? Next question, eighth one. Let A is equal to set of all x, y, z. B is equal to set of all 1, 2. Find the number of relations from A to B. Very simple. What we know? How many elements in A? Is n of A. Number of elements in A? 1, 2, 3. How many elements in B? 1, 2. There are 2 elements. So, how many elements in A cross B? It's nothing but n of A into n of B. So, it is 3 into 2, which is 6. Therefore, number of relations is nothing but 2 power n of A cross B. This is the form. So it is 2 power. What is n of A cross B? 6. So what is 2 power 6? You have to multiply 2 6 times. So it is, if you multiply this, you will get 64. So you will get 64 relations for the set A and B. Okay. Next, last question of this exercise. Let R be the relation on Z, that is integers, defined by set of all A comma B such that A comma B belongs to Z. So A comma B are integers. A minus B is an integer. Find the domain and range of R. So what is the relation? The relation is between two numbers. The two numbers are in integer. Their difference is an integer. So let us take two integers. What do you mean by integer? Integer is both negative value 0 and positive value together form integer. So let me take a negative integer minus 3 and let me take the positive integer 2. So their difference. So it is minus 3 minus 2, it is minus 5. It belongs to Z. So we know that the difference between any two integer is also an integer. If you take any number from an integer, take another number from the integer, find out the difference. The difference will be also in the integer system. So the difference between any two integer is also an integer. So let me start the solution. Difference between any two integer is also an integer. So if A comma B belongs to Z, A minus B, all A minus B will belong to Z. Okay. So therefore, domain. How to write domain? Domain is nothing but set of all first elements in relation. So what will be the first element? This A. So values of A which are in relation. Here all types of A will satisfy the condition because all the difference between two integer is also an integer. So all the integers which take part in A will satisfy the relation. So set of all first elements. So all A, values of A which are in the relation. So what is A? It is nothing but integer. So this is the domain. Okay. So in the same way we have to write range. So what is range? Set of all second elements in relation. Who is that? It is B. So values of B which are in the relation. Here B belongs to Z. So z. So integers. So all integers will satisfy this condition. So range will be values of b which are in the relation. Okay. So we cannot define a fixed set for this because the integers are endless. So we can form so many sets. So we cannot form the ordered pair for this relation. So just in general we can write all values of A and all values of B which are in the relation. Okay, they are also integers. Okay, so with this exercise 2.2 is completed. If you have any doubts, you can comment. Thank you. Thank you for watching. Bye bye.